Lesson. Transformations. Horizontal shifts. Personal transformation can and does have global effects. As we go, so goes the world, for the world is us. The revolution that will save the world is ultimately a personal one. Marianne Williamson. Question 1. The graph of function f is used to obtain the graph of function g. The graph of function g is a horizontal shift of the graph of function f. The graph of f is shifted 3 units to the left to obtain the graph of g. Part B. Write an equation for each function. The vertex form of a quadratic function is y equals a times the quantity x minus h everything squared plus k, where v of coordinates hk is the vertex. V of coordinates 0, 0 is the vertex of function f. Thus, f of x equals a times the quantity x minus 0 everything squared plus 0, which equals ax squared. The point of coordinates 1, 1 belongs to the graph of f. Thus, 1 equals a times 1 squared. Therefore, a equals 1. Thus, f of x equals x squared, which is the equation of function f. V of coordinates negative 3, 0 is the vertex of function g. Thus, g of x equals a times the quantity x plus 3 everything squared plus 0, which equals a times the quantity x plus 3 everything squared. The point B of coordinates negative 2, 1 belongs to the graph of function g. Thus, 1 equals a times the quantity negative 2, positive 3 everything squared. Thus, a equals 1. And g of x equals the quantity x plus 3 everything squared. Looking at the equation of g, we can conclude g of x equals f of x plus 3. Important, a horizontal shift 3 units to the left means the argument x of the function f is changed into x plus 3. If g of x equals f of x minus h, then h equals negative 3. A horizontal shift to the left means h equals negative 3. Make a table of values for f and g. For x equals negative 2, y is 4. X equals negative 1, y is 1. X equals 0, y is 0. X equals 1, y is 1. And finally, x equals 2, y equals 4. Take the corresponding shifted values of x for g of x by subtracting 3 from each of the x's. X equals negative 5, negative 4, negative 3, negative 2, and negative 1 respectively. For x equals negative 5, y equals 4. For x equals negative 4, y equals 1. For x equals negative 3, y equals 0. For x equals negative 2, y equals 1. And finally, for x equals negative 1, y equals 4. Important, a horizontal shift to the left 3 units operates as g of x equals f of x plus 3. Y of the transformation is equal to y of the parent. The argument of the function x plus 3 is the x parent, such that x parent equals x transformation plus 3. G of x transformation equals f of x parent. Question 2. The graph of function f is used to obtain the graph of function g. Part A. Describe the transformation. The graph of g is a horizontal shift of function f. The function f is shifted 1 unit to the right to obtain the graph of g. Part B. Write an equation for each function. The function f is an absolute value function. Its equation is f of x equals a times absolute value of the quantity x minus h plus k, where v of coordinates hk is the vertex. The vertex of function f is v of coordinates 0, 0. Thus, f of x equals absolute value of x. The function g is an absolute value function. The vertex of function g is v of coordinates 1, 0. Thus, g of x equals absolute value of x minus 1. Looking at the equations of f and g, we can conclude g of x equals f of x minus 1. Important, a horizontal shift 1 unit to the right means the argument x of the function f is changed into x minus 1. If g of x equals f of x minus h, then h equals 1. A horizontal shift to the right means h equals 1. Table of values for f. For x equals negative 2, y equals 2, x equals negative 1, y equals 1, x equals 0, y equals 0, x equals 1, y equals 1, and finally x equals 2, y equals 2. Take the corresponding shifted values of x for function g by adding 1 to every value of x, such that the table of values for g has x of negative 1, 0, 1, 2, and 3. For x equals negative 1, y equals 2. For x equals 0, y equals 1. For x equals 1, y equals 0. For x equals 2, y equals 1. And for x equals 3, y equals 2. Important, a horizontal shift to the right 1 unit operates as g of x equals f of x minus 1. Y of transformation equals y parent. X parent equals x transformation, negative 1, such as the argument of the function x minus 1 is x parent. And g of x transformation is equal to f of x parent. X transformation equals x parent plus 1. Fill in the tables below. Method 1. F of negative 4 equals 5. F of x negative 3 equals 5. Therefore, x minus 3 equals negative 4. Thus, x equals negative 1. G of 0 equals f of 0 minus 3, which is equal to f of negative 3, which equals 6. G of 5 equals negative 1. G of 5 is equal to f of 5 minus 3, which equals f of 2. F of 2 is equal to negative 1. Thus, x equals negative 2. Our next one, f of 4 equals 7. F of x minus 3 equals 7. Therefore, x minus 3 equals 4. X equals 7. G of 9 is equal to negative 8. G of 9 is equal to f of 9 minus 3, which equals f of 6. Thus, from those two we conclude f of 6 is equal to negative 8. X equals 6. Method 2. G of x equals f of x minus 3. Thus, yt equals y parent, and x parent equals x transformation negative 3. X transformation is thus equal to x parent plus 3. X parent equals negative 4. Thus, x transformation is equal to negative 4 plus 3, which is equal to negative 1. X transformation equals 0. Thus, x parent is equal to 0, negative 3, which equals negative 3. Thus, y parent is equal to 6. Thus, y transformation is equal to 6 because y parent is equal to y transformation. X transformation is equal to 5. Thus, x parent is equal to x transformation minus 3, or 5 minus 3. Thus, x parent is equal to 2. X parent here is equal to 4. Thus, x transformation is equal to 4 plus 3. Thus, x transformation equals 7. In this case, x transformation equals 9. Thus, x parent equals 9, negative 3, which means x parent equals 6. Extensions. 1. If a function has a horizontal shift, then the y of the parent function and the y of the transformation are equal. Y of transformation equals y parent. 2. If g of x equals f of x minus h, if h is greater than 0, then the graph shifts h units to the right. If h is less than 0, then the graph shifts h units to the left. 3. G of x transformation is equal to f of x transformation minus h, which equals f of x parent. 4. X parent equals x transformation minus h is equivalent to x transformation equals x parent plus h. Question 4. Describe the transformation. Part A. Y equals f of x. G of x equals f of x plus 3. Remember, g of x transformation equals f of x parent. Substitute x transformation and x transformation plus 3, which equals x parent. G of x transformation equals f of x transformation plus 3, which is equal to f of x parent. From these two, we can conclude x parent is equal to x transformation plus 3. Thus, x transformation equals x parent minus 3. Thus, g is a horizontal shift to the left 3 units. B. Y is equal to f of x. G of x equals f of x minus 1. Thus, x parent equals x transformation minus 1. Thus, x transformation equals x parent plus 1. Thus, g is a horizontal shift to the right 1 unit. C. Y is equal to f of 3x. G of x equals f of 3x plus 7. X parent is 3x. Thus, x parent equals x transformation plus 7. Thus, x transformation is equal to x parent minus 7. Thus, g is a horizontal shift to the left 7 units. Part D, y is equal to f of 2x negative 5. G of x equals f of 2x positive 8, which equals 2x negative 5 positive 13. X parent is 2x negative 5. Thus, x parent equals x transformation positive 13. Thus, x transformation equals x parent negative 13. Thus, G is a horizontal shift 13 units to the left. Question 5. Suppose that the x-intercepts of the graph of y of f of x are at negative 4 and 2. Part A. What are the x-intercepts of the graph of y equals f of x minus 3? The argument of the transformation has to equal to the argument of the parent function. Thus, x parent is equal to x transformation negative 3. Thus, x transformation equals x parent plus 3, and y transformation equals y parent. The x-intercepts of f are at negative 4 and 2. Therefore, the parent function, we can construct the table x equals negative 4, y equals 0, x equals 2, y equals 0. The transformation, remember, we add 3 to all of our x's, so x is negative 1, y is 0, x is positive 5, y is 0. The x-intercepts of the transformation are at negative 1 and positive 5. The x-intercepts of the transformation are at the points of coordinates negative 1, 0 and 5, 0. This is an example of the depiction of f and g. The x-intercepts of f are the points of coordinates negative 4, 0 and 2, 0. Then the x-intercepts of g are the points of coordinates negative 1, 0 and 5, 0. You see that the intercepts have been shifted 3 to the right, here to here, and this one to this one. Part B, y is equal to f of x plus 5, which is x parent. The argument of the transformation has to equal to the argument of the parent function. Thus, x parent equals x transformation plus 5. Thus, x transformation equals x parent negative 5, and y transformation equals y parent. The x-intercepts of f are at negative 4 and 2. Therefore, construct the table for the parent function. X equals negative 4, y equals 0, x equals 2, y equals 0. With our transformation, we subtract 5 from each of the x's. So x equals negative 9, y equals 0. X equals negative 3, y equals 0. The x-intercepts of the transformation are at negative 9 and negative 3. The x-intercepts of the transformation are at the points of coordinates negative 9, 0 and negative 3, 0. These are two examples of f and g. The x-intercepts of f are at the points negative 4, 0 and 2, 0. Then they are shifted to the left 5 units, such as the x-intercepts of g are the points negative 9, 0 and negative 3, 0. Question 6. Suppose that the function y equals f of x is increasing on the open interval negative 2, 4. Part A. Over what interval is the graph of y equals f of x plus 7 increasing? Y equals f of x plus 7. The argument of the transformation must be equal to the argument of the parent function. Thus, x parent equals x transformation plus 7, which is equivalent to x transformation equals x parent negative 7. Thus, the graph of y equals f of x plus 7 is a horizontal shift to the left 7 units. parent function, x parent belongs to open interval -2, 4. Transformation, horizontal shift to the left 7. Thus x transformation belongs to open interval -2, -7, comma 4, -7, which evaluates to open interval -9, -3. Thus, y equals f of x plus 7 is increasing on open interval -9, -3. A graphical example of a function f and its transformation. This graph f is increasing on open interval -2, 4. The horizontal shift of 7 units to the left produces graph g. Graph g is increasing on open interval -9, -3. Part B. Y is equal to f of x minus 7. The argument of the transformation must equal the argument of the parent function. Thus, x parent is equal to x transformation minus 7, which is equivalent to x transformation equals x parent plus 7. Thus, the graph of y equals f of x minus 7 is a horizontal shift to the right 7 units. For the parent function, x parent belongs to open interval -2, 4. Transformation, which is a horizontal shift to the right 7 units, x transformation belongs to open interval 5, 11. Thus, y equals f of x -7 is increasing on open interval 5, 11. This is a graphical example of an increasing function f, where f is increasing on open interval -2, 4. G is a horizontal shift to the right 7 units and is thus increasing on open interval 5, 11. Question 7. True or false? If f is an even function, then f of x plus 3 is an even function. Let f of x equals x squared. F is an even function. F of x plus 3 equals x plus 3, everything squared. The graph of f is an upward parabola with the vertex at the origin. The graph of f of x plus 3 is an upward parabola with the vertex at point of coordinates -3, 0. F has symmetry with respect to the y-axis. F of x plus 3 is a horizontal shift to the left 3 units and lacks symmetry as a result. Thus, f of x plus 3 is not even. We found an example of a function f that is even and f of x plus 3 is not even. Thus, the statement is false. Question 8. Always, sometimes, or never. If f has a local maximum at point of coordinates 2, 5, then f of x -1 has a local minimum at point of coordinates 3, 5. F of x -1 is a horizontal shift 1 unit to the right of the function f. The parent function has a local maximum at x equals 2, y equals 5. The transformation, where we add 1 to x because x transformation equals x parent plus 1, results in point of coordinates 3, 5, which is also a local maximum. A horizontal shift does not change the shape of the graph. A local maximum remains a local maximum. The statement is never true, and below we have an example of an upside down parabola that experienced a horizontal shift. The maximum remained the maximum. Question 9. Given that f defined on open interval -4, 8 closed interval, with values in closed interval -5 for open interval is a strictly decreasing continuous function, and g of x equals f of x plus 1, which of the following is true? Statement 1. G is defined on open interval -5, 7, close interval. The function g is a horizontal shift to the left 1 unit. Thus, the domain open interval -4, 8, close interval shifts to the left 1 unit. The domain of g is, which is open interval -5, 7, closed interval. Statement 1 is true. Statement 2. The range of g is open interval -6, 3, closed interval. A horizontal shift does not change the values of the y. The range of a transformation is the same as the range of the parent function. The range of g is closed interval -5, 4, open interval. Statement 2 is false. Statement 3. G of 7 is equal to -5. F is strictly decreasing continuous function defined on open interval -4, 8, close interval, with values on closed interval -5, 4, open interval. Thus, the highest value in the domain pairs with the lowest value in the range. Thus, f of 8 is equal to -5. In conclusion, g of 7 is equal to f of 7 plus 1, which is f of 8, which equals -5. Statement 3 is thus true. Statement 1 and 3 only are true. Thus, the correct answer is E. Question 10. The function f, defined as f of x equals x cubed -15x squared positive 75x -125, is neither odd nor even. For what value of h is the function g of x equals f of x minus h, an odd function? Let's recall the binomial cube formula. A minus b everything cubed is equal to a cubed -3a squared b positive 3ab squared negative b cubed. In this case, a is equal to x and b is equal to 5. The polynomial compresses into a binomial cubed. F of x equals x minus 5 everything cubed. F of x plus 5 is equal to x plus 5 minus 5 everything cubed, which simplifies to x cubed. G of x equals x cubed is an odd function. G of x equals f of x minus h.